This is problem number 3 on the practice problems for test number 2. Solve each of the following quadratic equations using the algebraic method of your choice. A, 3a squared minus 21 equals 0. So you're welcome to use the quadratic formula for every problem on this page, every part of number 3, but it turns out that there are sometimes easier methods, shorter methods to solve quadratic equations. So I'm going to go for the shortest method I can think of for each of these. So in this case, I'm just going to point out normally our quadratic equations look like ax squared plus bx plus c equals 0. And this one kind of looks like that. There's a squared term, there's a constant term. What's missing is this bx term. There's no term here with just a. And whenever that happens, I get pretty excited because solving the equation is really, really easy in that case. If you take a few steps to isolate the a squared, we're going to get there pretty quick. So first I'll add 21 to both sides. Then I'll divide both sides by 3. And then finally take the square root of both sides. I said divide by 3, probably should have done it. Take the square root of both sides, and we get a equals square root of 7. So it's quick, pretty painless. The problem is it's really easy to make the mistake that I made here. Well, not the 21 divided by 3. I'm sure you didn't make that mistake. But the mistake is that we forgot to put in a plus or minus. It's so easy to forget that. And the reason that it comes in is because the square root of a squared isn't just a. The square root of a squared is actually the absolute value of a. And so if we just did one more step, the way to get the absolute value out of there is to introduce the plus or minus on the right-hand side. So a is plus or minus the square root of 7. I don't know of a good way to get folks to remember when you take the square root of both sides of an equation, you must put in the plus or minus. Maybe this is memorable to you that the square root of a squared isn't just a, it's absolute value of a. We talked about even indexed roots and the absolute value getting its revenge, even revenge. And if you get the absolute value, then maybe you'll bring in the plus or minus. For what it's worth, if you did the quadratic formula on this problem, you would get the plus or minus because the plus or minus is built into the quadratic formula. So every quadratic equation has 2 answers. Now, occasionally those 2 answers happen to be the same number, but just about every time, quadratic equation will have 2 different answers. So if you just stopped at square root of 7, maybe a little warning bell goes off in your head that says, wait a minute, quadratic equation has 2 answers. That squared up there tells you there's going to be 2 answers. Almost always they're 2 different numbers. Part B, 2x squared plus 4x plus 9, 2x squared plus 4 equals 9x. So I'm going to get this to look like the top left blue equation up there, the ax squared plus bx plus c equals 0. So we do that by getting the right-hand side equal to 0. I'm going to subtract 9x, but I'm going to do it in a way that puts the 9x right in the middle where it belongs. So now it's in standard form. It looks like the top left blue equation. And you're welcome to use the quadratic formula now. I'm going to spend a moment trying to factor this one. It's a little bit annoying because there's a 2 in front of the x squared. So unfortunately, we can't just do our product sum thing because of the 2. Our product sum thing only works when there's a 1 in front of the squared term. So you can do the book's rectangle method, the box method. You can do trial and error. I'm going to do funky factoring. So the first step is to take that leading 2, which we don't like, and shove it into the constant term by multiplying. So x squared minus 9x plus 8 equals 0. Now you can do the product sum thing because in front is a 1. So pause the video here, see if you can find the 2 numbers that give you the product of 8 and the sum of negative 9, and then come back when you've got it. So hopefully you came up with x minus 8, x minus 1. Notice the equal 0 appears every single time. Okay, so I think we're ready to just dive into the 0 product property, right? X minus 8 is 0, or x minus 1 is 0. But we made a mistake here. We haven't finished the funky factoring. We took the 2, it's circled in black there, and we moved it out of the way. Well, it comes back. Before you solve this equation, it comes back. So I'm going to copy everything here, but I'll leave a little space in front of the x. I'm going to bring that 2 back in front of both terms. And then the idea is to divide each of those parentheses separately by their own greatest common factors. So what goes into 2 and 8? 2 goes in. What goes to 2 and 1? Just 1. So let's do our division here. That 2 in the bottom goes into the 2x and gives me just x, minus the 2 also goes into the 8, gives me 4. Divided by 1 doesn't change anything. And now the factoring is complete, so we can use that zero product property and write down 2 brand new equations, much easier than any equations we've had in this problem. For the first equation, add 4. Second equation, add 1, and then divide by 2. So we have our 2 answers. X equals 4, x equals 2. Or we don't. Let's try that again. If we divide by 2, we get 1/2. Okay, part C, x squared minus 4x plus 5 equals 0. It's already in standard form, this top left blue equation. So you can try to factor. It looks like there's potential to do the product sum thing. Looking for 2 numbers whose product is 5 and whose sum is minus 4, so maybe something like x minus 5, x plus 1. But unfortunately, that doesn't give you positive 5, it gives you negative 5. Okay, so what if we try minus 1? Okay, so now you've got the plus 5, but you don't have minus 4x anymore. Now it's a plus 6 or minus 6x. So unfortunately, even though it looks like it might factor, it doesn't. So as soon as I spend a moment looking for the product sum and not finding it, I just dive right into the quadratic formula. So pause the video, see if you can remember the quadratic formula, and then come back when you've written it down. So we've got our quadratic formula there. I'm pretty sure I heard some of you guys humming. And now we'll identify the a, b, and c from the equation. So remember the a is the number in front of x squared, b is the number in front of x, c is the number without a constant on it. 1, don't forget to grab the negative 4. It's not just 4, it's negative 4, and then 5. Okay, so now we just need to plug these numbers into that big old formula. So negative b becomes positive 4, plus or minus square root of b squared, negative 4 squared, minus 4 times a, 1, times c, 5. Divide by 2 times a, 2 times 1. Now, it's tempting to just go to the calculator. I encourage you to not go to the calculator. Not only are these numbers fairly easy to compute without the calculator, the expression you get from the quadratic formula is so complicated, and there's so many parentheses that I find it very error prone to type it into the calculator as it is. So do as much as you can without, or at least if you're going to use the calculator, do it in pieces. So negative 4 squared, is that positive 16 or negative 16? It's positive. Make sure you put the parentheses around the b. In fact, if you wish, in the quadratic formula, you could just automatically put parentheses around that b every time. The whole thing always gets squared. Minus 4 times 1 times 5, 20. Divided by 2 times 1 is 2. 4 plus or minus square root of 16 minus 20, negative 4. Okay, at some point in the not too distant past, we would have stopped right there and said this is not a real number. But now that we've seen the imaginary numbers, we can go further. 4 plus or minus, I see a square root with a negative, I make it positive, and I bring something out in the front. What is that something? It's I, our imaginary number. Still divide by 2. 4 plus or minus. So the square root of 4 happens to be a nice number, so let's bring it out. It's a 2. And normally you'd stop there, but in this case, if we split this up into 2 fractions, we'll be able to reduce each of them. So let's do that. So 2 fractions with a 2 in the denominator of each. 4 plus or minus 2i. And then finally, 4 over 2 is just 2. 2i over 2 is just I. 2 plus or minus I are the 2 answers. Okay, and we'll come back now finally to part D. X squared minus 2x equals 11. So first, again, want to get that one side to 0 to get it in standard form. So subtract 11 from both sides. Notice I put the 11 there where the constant normally goes. Okay, and maybe take a moment, pause the video, see if you can do the product sum. Come back when you've got it. Okay, hopefully you didn't spend too much time. Maybe you didn't leave it all, but in this case we can't factor it. There's no numbers whose product is negative 11 and whose sum is negative 2. No integers at least. So again, we're using the quadratic formula. So we just have to identify the A and the B and the C. Don't forget to grab those negative signs with the A and the B and the C. And then we're just jumping into the quadratic formula again. So let's try it. X equals negative B. That becomes positive 2. Plus or minus square root of B squared, negative 2 squared, notice the parentheses, minus 4 times A times C. All divided by 2 times A. Again, with small numbers like this, I'd encourage you to leave that calculator alone. Negative 2 squared is positive 4. 4 times 1 is 4, times negative 11 is negative 44. That's going to turn into a plus in there. Two plus or minus square root of 44 over 2. Okay, so we've got two real numbers. In some problems, we just stop right there. But again, if we could simplify, we should, and that square root of 44 can be simplified. So pause here, take a moment to see if you know what I'm talking about when I say simplify that square root of 44. So hopefully you've split that 44 up into two factors, one of which is a perfect square. And then we'll use that nice property of radicals. It says when you have the square root of a product, you can split it up into two radicals and multiply them at the end. I'm just going to skip to the part where I bring that 4 outside, keep the 11 inside. And I see lots of 2's. I feel like we should be able to cancel. I'm going to do it really carefully, just like in the previous problem. Split it up into two fractions and then do them separately. So we cancel 2 over 2 and get 1. 2 over 2 again, and the second fraction is 1. So we just get 1 plus or minus square root of 11. So I'm sure lots of you caught this error a while back. I thought I heard some of you screaming at me, but I ignored it. So let's fix it real quick. So right up here, it said 4 minus negative 44. I said that turns into a plus 44, and I completely ignored that 4 in the front. So this should have been a 48. Let's fix that. Now when we factor, still going to factor out the 4, but it's now 4 times 12. And in fact, we can factor out more than 4, so let's factor out even more. A bigger perfect square that goes into 48, 16. So that's really 16 times 3. And then the 16 comes outside as a 4. 3 stays inside. And then we'll split it into two fractions just like before. So this time we'll do the right fractions. So that's 4 and that's 3. And then when we reduce this, so here 4 and 2 cancel, and we just get a 2. Square root of 3 stays as it is. And so that's our final simplified answer, 1 plus 2 square root, 1 plus or minus 2 square root of 3. And that's good, it's reduced. I'd also like us to be able to use the calculator to get that. So take your calculator out if you don't have it out yet, and see if you can get the 2 decimals. Pause the video and come back when you think you've got it. Type it in really carefully, and then come back. Okay, so for this calculator, I'm doing 1 plus 2 square root of 3. And actually on my calculator, I have to do it in a kind of a funny way. I have to type in the square root, no, I'll do it like this. 1 plus 2 times, and then for me, square root of 3 is kind of opposite from what other calculators sometimes do. I hit 3, then I hit the square root button. That 1.73 is just the square root of 3, so I have to hit equals to get the final answer, 4.464. So we'll have 4.464. And then we'll do the other number. Unfortunately, I have to start over. 1 minus 2 times square root of 3 equals, and we get negative 2.464. And those are the two answers. I'll do it one more time on a different calculator. So if yours looks like this, it's a little bit easier to type it in. 1 plus 2, don't need to do the times anymore, but the square root key is right there in yellow. 1 plus 2 square root of 3, we hit enter. That number looks familiar. Instead of retyping, if you hit second and then the enter on the bottom right, it recopies the previous line. So I'm just going to mouse over, arrow over, and change that to a subtraction sign. And that gives us our other answer.